Okay, so we're going to go right into it and do your Unit 5 final review. So Unit 5 was all about triangles, and one of the key elements was vocabulary. So we want to make sure that we know these vocabulary words as we review all the different parts of the triangle. So the first one is a median. And so what do we mean by a median? Well, a median is going to be a line inside of a circle. And so a median connects the opposite vertex, a vertex to the midpoint of an opposite side. So this is a segment, segment connecting a vertex to the midpoint of the opposite side. So if we think about that in a picture, so if you have some sort of a triangle, right, then, all right, off to a good start here, right? If I have a triangle and I want to find the median, I would take the midpoint of one side and I would connect it to the opposite vertex. This right there would be the median. The altitude is the same. It goes, so this is a segment connecting a vertex to the opposite side, but the difference from the median, whereas a median connects to the midpoint, the altitude is perpendicular to the opposite side. So an altitude is a segment connecting a vertex to the opposite side and is perpendicular to that side. So think about another example. We have a triangle. If I connect this vertex to the opposite side and make this perpendicular, that's a right angle, then this line right here is an altitude. Notice it doesn't have to be the midpoint. It could be, but not always. Right, and then we have a circumcenter. A circumcenter is going to be the intersection of all the perpendicular bisectors. So the intersection of all perpendicular bisectors inside of a triangle. What's a perpendicular bisector? Ooh, right down here. So a perpendicular bisector is a segment that bisects another segment, we can call it, a line. So a segment that bisects another segment and is perpendicular. It's a good way to write it. So if I have two segments, so there's one, and there's another one, this would be a perpendicular bisector as long as this segment here is bisected and these two are perpendicular. That is a perpendicular bisector. A bisector, well, we could have an angle bisector bisects an angle. It cuts an angle into two equal halves. And then you have a segment bisector, which cuts a segment into two equal halves. So you can have an angle bisector or a segment bisector, but both of them just take the angle or the segment and cut it into two equal halves. So take a little detour there. But getting back up here to an orthocenter, what is an orthocenter going to be? Well, an orthocenter is going to be the intersection point of the altitudes. So this is going to be the intersection of all altitudes inside of a triangle. The centroid is going to be the intersection of the medians inside of a triangle. So where the medians intersect, that's the centroid. Where the altitudes intersect, that's the orthocenter. And where the perpendicular bisectors intersect is the circumcenter. Now the incenter, that is going to be the intersection of all the angle bisectors. The intersection of the angle bisectors inside of a triangle. Yeah, so know these vocab words, know them, understand the relationship between them. This is a centroid theorem, and what this says is that if you have a centroid, which, remember, is the intersection of all the medians, then if you have these medians, these are going to be cut into a ratio of 1/3 to 2/3. So if this whole, let's say that this whole distance here is 3, then this part would be 1, and this would be 2. Notice that SA is 1/3 of the entire segment SF, and AF is 2/3 of the entire segment SF. So here, SA, which would be 4Z, is equal to 1/3 of the entire segment, which would be 4Z plus 4.6. Simplifying this, if I multiply both sides by 3, I get 12Z. Don't have to worry about any fractions. Is equal to 4Z plus 4.6. Subtract the 4Z, so I get 8Z is equal to 4.6. And that means that Z is going to be equal to 4.6 divided by 8, which is 0.575. And we can set up the rest of these in a similar fashion using this method. So if we look at y, I can see that this line, this is actually longer, right? So y is actually going to be 2/3 because this is the longer segment of the two, EA and AU. That's going to be 2/3 of y plus 2.9. And here, we could distribute the fraction. We don't have to. I guess in this situation we are kind of stuck, but y is equal to 2/3 of y plus, if we take 2/3 and we multiply that by 2.9, we're going to get, if I take 2.9 times 2, I'm going to get 5.8 over thirds, right? I just multiply this 2/3 times 2.9. 2 times 2.9 is 5.8. I don't like fractions, so I can multiply everything by 3. So I get 3y is equal to 2y plus 5.8. If I multiply each term by 3, the denominators cancel. I can subtract 2y from both sides, and I get that y is equal to 5.8. I like to put little boxes around my answers so I know what they are. And then finally, I have x. So x is this distance. That's the 2x minus 5. And again, that's going to be 1/3 because it's a smaller segment. 1/3 of 2x minus 5 plus 6. So this whole distance. So we get 2x minus 5 is equal to 1/3 2x plus 1. Again, I can multiply both sides by 3, so I don't have to worry about dividing by 3. So if I multiply both sides by 3, I get 6x minus 15 is equal to 2x plus 1. I can combine my like terms. So I get 4x. Yep, 4x from subtracting the 2. 4x is equal to 16. That's 15 plus 1. So x is equal to 4. So those are my answers for this. So it's a nice centroid theorem again. Centroid, intersection of the medians. It cuts every median, each median, into a ratio of 1/3 to 2/3, 1 to 3. So as long as you can set up some equations here, work through these, you'll be fine. All right, angle-side relationships, or side-angle relationships, are how do the angles inside of a triangle and the sides relate to one another. Well, if I have a triangle and use this, I'm really going to exaggerate here. If you look at here and I ask where is the smallest angle, you correctly say it's this. Where's the smallest side? Right here. The sides go in the same order as the angles. So this is the smallest angle. This is the smallest side. This is a right triangle. So that means that 90 degrees is going to be the largest angle, and the hypotenuse is going to be the largest side. Notice largest angle, largest side, smallest angle, smallest side. So if I have here, and I'm asking for the sides in order of this triangle, first off, I should find the angles. Now, these angles, I don't have the exact measurements of. However, it being a triangle, if I add all of the angles together, they must be equal to 180. And so if I combine my like terms, 12n minus 3n plus 16n, that's going to give 9n plus 16 is 25n. Negative 9 plus 62 plus 2 is 55. If I subtract 55 from both sides, I get 25n is equal to 125, or n is equal to 5. So if n is equal to 5, I can plug these back in. 5 times 12 is going to be 60, minus 9 is 51. 62 minus 3 times 5, which is 15, so 62 minus 15 is going to be 47. And then 16 times 5, that's going to be 80. And if I add 2, that's 82. So in terms of the angles, which order do they go in? Angle Q is the smallest, followed by angle P, followed by angle R. Now this is not what they're asking for. They're asking for the order of the sides. So the sides are going to be the letters that don't include the angles. So which side is opposite of angle Q? That would be side PR. What would be opposite of P? QR. And which side is opposite of R? QP. This is my correct answer. If we struggle with that, we can draw a triangle. It doesn't have to be perfect. And here we can see, if this is angle Q, which side is opposite that? PR. There we go. So work this out. Remember, if you don't know the measures of angles, triangles always add up to 180 degrees inside, so use that to help you through it. Now, triangle inequalities are what can be a triangle. So if you have two segments that are equal, and let's say I cut this one into two parts. They're still equal. However, if I take this and I pick this point and draw it up, now I have something that looks like this. Well, notice I couldn't make a triangle of this because I'd have excess space over here. So the only way for this to be a triangle is if these two sides added together are greater than this third side. And that's what a triangle inequality is. The sum of two sides must be greater than the third. So if I look at here, if I have three sides, it must be true that 4 plus 7 is greater than 13, but also that 4 plus 13 is greater than 7, and that 7 plus 13 is greater than 4. All the different combinations. So if I look at this, I get 20 is greater than 4, and that's perfect. I get 17 is greater than 7. Yep, that works. But here I get 11 greater than 13. No. So because only 2 out of the 3 of these inequalities work, the answer is no. If you think about it over here, again, the 3 inequalities we're going to have, 3 plus 4 must be greater than 6. 3 plus 6 must be greater than 4. And 4 plus 6 must be greater than 3. 3 plus 4 is 7. And 7 is greater than 6. 3 plus 6 is 9. And is that greater than 4? Yep. And 4 plus 6 is 10, which is greater than 3. So all of these work out, so the answer is yes. So make sure you understand the difference there. All right, centroid is again the intersection of centroid is the intersection of the medians. So what we want to do to draw this is to find the medians. So I'm going to use my tools. If I can find out, it's been a while since we've done this, where the, there we go. I'm going to need my compass. So when we do this using a compass, we want to find the midpoints of all these lines. So if you remember how we found midpoints before, we don't just measure. We actually take this compass and we go a little bit more than halfway, and we draw an arc. And I do this from both sides there. And then so if I draw a line connecting these 2 points, then that means that where this intersects the circle is going to be the midpoint. And if I get rid of all of these, if I get rid of this line there, I can see that's my midpoint. So that must mean that the median goes from that midpoint to the opposite vertex. And so what I want to do is I want to do that with all of the others as well. So I'm going to start with C down here. And I'm going to position my compass so that I'm not sliding the paper. I'm going to position the compass as I was saying, I'm going to position this compass so that's a little bit more than halfway of where I estimate the halfway point to be. Draw a nice little arc. And I'm going to do the same from the other side, not moving it. And so here, these are actually really close. I don't even need that line because I can guess that this midpoint is right there. So that must mean that this midpoint, if I make my line red to match, this midpoint connected to this opposite vertex is going to be the median. And now I can already see that the intersection of these two is going to be the centroid, but let's just find that third side for good measure. And in order to do that, I need to find the midpoint of this bottom side, AC. move this. That looks about good. Draw. There we go. Cut it just a little bit too short, but it's all right because I can still see this intersection point. Right? If I drop this line there, then I know that my midpoint of this line is going to be right there. So if I get rid of that one marking, connect this to the opposite vertex, there we go. And now I can see where is the centroid. Right there. And I can even say that this is the centroid. All right, so that's how we find the centroid, by finding the medians and find their intersection. All right, now the orthocenter. For the orthocenter, we have to find the intersection of all of the altitudes. And so in order to find the altitudes, we need to find perpendicular lines to all of these sides. So what we need to do is we need to draw perpendicular lines to the opposite vertex. So if we look at here, we can't just draw this and then say, oh, that looks perpendicular. We actually need to intersect this at a 90-degree angle. So if I start with angle C here, actually, I'm going to move this like so, just so it's a little bit larger. I'm going to draw this arc here. Now notice, this arc here intersects this side at these 2 points. So what I want to do is I want to find the midpoint of those. And so again, using this, I might not have enough space here. Yeah, we got it. Moving this. Looks like it'll be all right. Do the same process as before. Well, that's right on the money. And there's going to be some point there. So if I connect this to the opposite side, there we go. That means that this is now perpendicular. And so we should do that from all of the other same sides. So let's do red. And we are going to move this over here. Now I want to position this in a way that when I draw this, it's going to make a nice little arc. So maybe move it one over. Yeah, that should be okay. And so when I draw this, there we go. We can see we've made 2 points there. And so now I want to find the midpoint of those two. So I'm going to need to pull this in really close there. Doesn't matter where I put this as long as it looks like it's going to be more than halfway. There we go. And so the midpoint's going to be somewhere between there. So actually it looks like it's going to be right about there. And then so if I connect that to this side, we can see we're going to have this other perpendicular line. And so we can already see that this point right here This is going to be the orthocenter. And so that must mean that this last line, this last altitude, is going to go from here straight through to that point. So actually off by a little bit. And when you do this by hand, especially the larger the pen you do it, you can see that this is really large. It's not going to be exactly on point, but the finer tip you use, the more accurate this will be. But of course, I'm not going to be too specific with this. And then finally, the incenter. Don't forget that the intersection, the incenter is the intersection of all of the angle bisectors. So we need to bisect all of these angles. So we bisect these angles, again, using a compass. And actually, I should probably do this. Okay. So we're going to do, from the angle, we're going to draw a nice little arc. And then, not changing that, we're going to draw 2 more arcs. As such. And then where they intersect is where the line, the bisector, is going to pass through. So this angle bisector is going to go right through there. Next up, I'm going to do the angle bisector of C. And I don't have to keep this the same, but as long as I'm working to the same angle, I have to keep those two the same. So make my arcs there. And make this arc here. And again, we can see that red intersection point. So we want to pass this through that intersection. We can already see where these two intersect is right there. So hopefully our third angle will also do that. And there we go. And if I draw this arc there, and that arc there, I can now connect this with a straight line. And where that intersects those two is the angle bisector. I could probably get rid of all of these curved lines so we can better see. That's not what I want. So I can better see where this incenter is. Whoops. Don't want to delete the triangle. That's not going to help you. And there we go. So I still got this one curved line in there. We can see that these angle bisectors all intersect right here. And so that is the incenter. So get some practice with those. There are plenty that we did in class, so check those out. All right, and then finally we have this. We want to, we're given a triangle, and we want to find the coordinates of the centroid. Don't forget, the centroid is the intersection of the medians. So medians connects the vertex to the midpoint. So we want to find the midpoint of AB. So midpoint formula is going to be x1 plus x2 over 2, comma y1 plus y2 over 2. And so in this case, AB, that's going to be 4 plus 4 over 2, comma 6 plus 11 over 2. This is going to be 8 divided by 2, which is 2. Sorry, 8 divided by 2. 8 divided by 2, which is 4. And then 16 plus 11, which is just going to be 17 over 2. I'm going to leave it as a fraction. That's fine. I want to find the slope of the line between the midpoint of AB and C. So slope. Slope is whoops, slope is m. So m is equal to y2 minus y1 over x2 minus x1. And so this is going to be the change in the y's. So 6 minus the midpoint of AB, 17 over 2, over change in the x's, so 4 minus, we should write this in the same order. So if 6 corresponds to C, we should have 9 corresponding first. Simplifying this, 6 is 12 divided by 2, and I'm going to need that for a common denominator. 9 minus 4 is 5. 12 minus 17 is negative 5. So I get this. However, don't forget, if I have negative 5 halves divided by 2, that's negative 5 halves divided by 2, which is the same thing as negative 5 halves times 1 over 2, because we multiply by the reciprocal. And so this gives us a slope of negative 5/4. A little bit of algebra there. We can get some more practice with that. Don't be too concerned about the difficulty of the algebra. The geometry is the important part. All right, and we want to find the equation of the line between the midpoint of AB and point C. So we know a point and we know a slope, so we can use that. So point C is 9, 6. So I'm going to do that. So I'm going to do, well, don't forget, this is y minus y1 equals m times x minus x1. That's point slope form. So we're going to do y minus 6 is equal to negative 5/4 times x minus 9. Ooh, I ran out of room quickly. All right, so this is going to be really quickly. Y minus 6 is equal to negative 5/4 x. If I multiply, I'm going to get 45/4. And then if I add the 6, y is equal to negative 5/4 x. If I add the 6, that's 24/4. So if you do 45 plus 24, that's going to be 69/4. And leave these as fractions. It's going to make your life a whole lot easier. All right, now we want to find the midpoint of BC. So BC is again going to be the x's, so that's 4 plus 9 divided by 2, and the y's, which is going to be 11 plus 6 divided by 2. Okay, so this is going to give us 13 halves, 17 halves. We want to find the slope of the line between the midpoint of BC, so this point we just had, and A. A, don't forget, is 4, 6. So if we do 6 minus 17 halves over 4 minus 13 halves, using our common denominators, we're going to get 12 over 2 minus 17 over 2 divided by 8 over 2 minus 13 over 2. So this is again negative 5 over 2 divided by, and this down here is going to be also negative 5 over 2. Well, when I divide something by itself, I just get 1. So that's simple. So find the equation of the line between the midpoint of BC and A. Well, I like A because it doesn't have fractions, which is 4, 6. So again, if I do y minus 6 is equal to the slope, which is 1, of x minus 4, I get that y is equal to x minus 4 plus is 6 plus 2. So find the intersection of the two lines, okay? The intersection of two lines is where they meet, so where their x values and their y values are the same. So if I set their equations equal to each other, so in this case, x plus 2 is going to be equal to negative 5/4 x plus 69 over 4. All I have to do is solve for x. Now I know those fractions are intimidating, but again, if I multiply everything by 4, I get 4x plus 8 is equal to negative 5x plus 69. It reduces, it cancels out the fractions. If I add 5x to both sides, I get 9x. If I subtract the 8, I get 61. So x is equal to 61 over 9. And so what are the coordinates? Well, if I know that x is equal to 61 over 9, y is going to be x plus 2. So y is going to be equal to 61 over 9 plus 18 over 9. And so that means that y is going to be equal to 79 over 9. So the point is 61 over 9, comma 79 over 9. So again, a lot of good work with the fractions. And with some algebra, but as long as you can understand midpoint, slope formula, distance formula, we didn't use distance formula, midpoint formula, slope formula, and the equation of a line, then you are all set. So make sure, again, going back here, you understand the vocabulary, what all these are, and for anything you don't understand, just make sure you get more practice with it, and I'll be happy to review anything that you do. Best of luck.